So we're looking at section 9.1. We're going to be adding and subtracting rational expressions. So first thing we want to do is identify excluded values. So if we're given a rational expression, identify the excluded values by finding the zeros of the denominator. Remember, anytime we divide by zero, we have an issue. So that's when we're going to have domain issues. So the denominator of this expression is x minus 1. Since division by 0 is not defined, the excluded values for this expression are all the values that make the denominator equal to 0. So set x minus 1 equal to 0 means we'll have an excluded value of x equals 1. So if we want to simplify the expression, we first factor the numerator. 1 minus x squared, it's a difference of squares. It'll factor to 1 minus x, 1 plus x. And then we want to divide out terms that are common to both the numerator and the denominator. So the numerator we said was 1 minus x, 1 plus x. Since we're trying to cancel stuff out, we factor out a negative from the denominator. We'll end up with a negative of the quantity 1 minus x. So that means those can cancel. We'll be left with negative of 1 plus x, which is the same thing as negative 1 minus x. So this expression simplified is negative 1 minus x whenever x is not equal to 1. So what is the domain of this function? Again, that's based on our issues. That's x cannot be equal to 1. What is the range? So to think of the range, we think of the outputs. Well, if our function simplified to negative 1 minus x, we know our domain issue was at negative 1. So if we plug that in, we'll get a range of y cannot be equal to a negative 2, because negative 1 minus 1 is negative 2. So what factors can be divided out of the numerator and the denominator? Common factors. So when we simplify expressions, we want to divide out the common factors. If we're given a rational expression, there are different ways to write an equivalent rational expression. When common terms are divided out, the result is an equivalent but simplified expression. So in this case, we wanted to rewrite 3x over x plus 3 as an equivalent rational expression that has a denominator of x plus 3, x plus 5. So what we'll need to do is multiply by something that's equivalent to 1. So in this case, it'd be x plus 5 over x plus 5. Do that multiplication, and you'll get the equivalent expression. So here we want to simplify this expression. So you write it out, and then we need to factor. So the numerator is going to factor to x plus 3, x plus 2. The denominator will factor to x plus 2, x plus 1, and then that x plus 3. So we can see all the things that are canceling. Those x plus 3s will cancel. The x plus 2s will cancel. So once we've divided out the like terms, we're left with 1 in the numerator and just that x plus 1 in the denominator. We want to rewrite 5 over 5x minus 25 as an equivalent expression with a denominator of x minus 5x plus 1. So right now, we simplify already a little bit. We can factor a 5 out of the denominator. So those 5s will cancel out. We're left with 1 over x minus 5. Since this is what we want in our denominator, we'll need to multiply by something equivalent to 1. That will have a value of x plus 1 to get it into our denominator. So this will give us with the function x plus 1 over x minus 5 times x plus 1. We want to write 3x cubed over 3x minus 6 as an equivalent expression with a denominator of 2 minus x, x squared minus 9. So first thing we can do, again, we want to factor out what we can from the denominator. And there we can see that those 3's are going to go away. So we've got x cubed over x minus 2. So that means the only piece we're missing in our denominator is the x squared minus 9. So we'll multiply by something in terms of that that's also equivalent to 1. So that's x squared minus 9 over x squared minus 9. And we'll get x cubed times x squared minus 9 over x minus 2 x squared minus 9. Now this still doesn't look quite the same because this is actually 2 minus x. So what we'll do in the denominator here, we'll factor out a negative from that first expression. And that will change our signs. So we'll get 2 minus x, and then the x squared minus 9. And there we have what we were looking for. We want to simplify this expression. The first thing we want to do is factor. So the first term in the numerator, we can factor out an x. We'll be left with, 1 plus x squared. And then 1 minus x squared is a difference of squares, so it factors to 1 minus x, 1 plus x. And then denominator, we can factor out an x squared. We're left with 1 minus x to the 4th. Well, that's another difference of squares. So we can factor that into 1 minus x squared, 1 plus x squared. And that 1 minus x squared in the denominator is another difference of squares. So we can factor again to get our final factorization, and then we can cancel what we can. So 1 minus x, 1 plus x, and then the 1 plus x squared. So now that we've factored completely, you can see the things that are dividing out. 1 plus x squareds go away. Oops, 1 minus x's go away. 1 plus x's go away. And now we've got an x and an x squared, so that's going to get rid of one of those x's. So everything in our numerator is gone. We're left with 1. Our denominator got rid of everything except an x. So this is our simplified expression, 1 over x. Okay, first thing we need to do is factor. So this will factor to x minus 8, x plus 3. In our denominator, this is a difference of squares. So it'll be x minus 8, x plus 8. The minus 8's divide out. We'll be left with x plus 3 over x plus 8. And our last one, with just simplifying, when we factor, we'll factor to x minus 8, still with that x plus 2. We've got a difference of squares, so we'll factor to x plus 8, x minus 8. And then this factors to x minus 8, x plus 2. So when we see what divides out, the x plus 2's go away. The x minus 8 go away there. X minus 8 goes away there. Everything's gone from our numerator, so we're left with a 1. And then all that's left in our denominator is x plus 8.